I want to start off with a couple notes. This is a very fast-moving field, topic, adventure, whatever you want to call this whole thing. Everything that is LLMs, Gen AI is not something that you can even like attempt to pin down. Everybody's at a similar point. So I am going to start very basic, and I apologize to everyone who doesn't need that, but hopefully it will be useful to everybody else who's there, and then we can build up from that. I'm hoping for all sorts of great questions towards the end, and some of this will just be kind of like a staging point for conversation. Um, so, what am I talking about today? AI on your own terms. Really, this is, open source, running your own models, being in control of, you know, the entire stack. Do you really need to run on somebody else's cloud to use AI? Of course not. I say not anymore, but you didn't really need to from the beginning. I guess one of the more significant differences of late is the open models are getting better and better. We're getting closer to somewhat parity with the big proprietary things. You're not going to necessarily expect to solve undisclosed Erdos problems with a local model right out of the gate, but hey, you don't sell yourself short. You might. So, what's the value of trying to run these things yourself? It's pretty straightforward to go to an OpenAI, Anthropic, etc., and pay for tokens, pay for access to a web portal. Man, Anthropic is coming out with a cool new, toy every other month, it feels like. And so like there's a new app, Cowork, some kind of finance or legal kind of specific version. Why not just do that? Well, one of the things that I do want to point out is you can just do that. Like running your own models, running your own stack, building, tinkering, etc. That doesn't have to be exclusive to, like, you can, but you don't have to be a purist. It's not I am only running open source because, you might have some kind of moral focus there, but at least myself, I'll run Claude Code on the side to get some tasks done, and I'll also have my own open source stack and kind of tinkering setup, and kind of like it's great for other things. So what are some of the main selling points? Well, privacy, of course. Everything that you build is local, or whatever kind of service that you want to hook it up to. You don't have to ask, where did my data go? What are the terms of service? Did they change on me last month? Um, you have control. Specifically, you choose the model. That model is, if you were in some large organization, you'd probably have this versioned. But if you're local, it's an artifact. You've downloaded that. That's not going to change on you on Thursday, and you'll get some kind of behavior regression, and everybody has to complain about, oh, the model that I grew to love and rely on, it's just different this week because some service changed. Um, One thing that comes with that control, of course, is that you get to extend this thing. There's so many ways in which you can, extend an open model. You have the ability to continue to train on top of it. You can train LoRa's, which are kind of like a type of quick training, um, worth looking up. We're not going to go down that road too much here, but you can kind of customize and personalize these things. If you are going for kind of significant cost savings, you could even, take a little bit of that and a smaller size model and really hone down on a couple very specific capabilities that you need out of it. Hardware, it's a tricky one though, because it is it's nice to save money in the long run, but some of the hardware to get you up and going can be quite expensive. And so, like, one of the hopes and dreams is you can, take advantage of the hardware you already have, especially right now when it costs an arm and a leg and a foot to buy a simple stick of RAM. But that's just kind of a piece that you have to work around. Once you do have the hardware up and running, at least you're not specifically kind of watching your per token meter use. I find in particular, if I'm running some kind of long running task, it's just comfort of not knowing that I have to optimize the behavior of some kind of workflow or agent to say, I really need to, make all of the tokens count because each one is going right out of the bank. You know, it's just a little more free form. You can kind of start to figure out what you are trying to do and not worry about the details. As I said, curiosity, a lot of what drives me in this open effort is learning, Like, as I mentioned, this whole field goes very, very fast. And like part of what is valuable in running things yourself is you can go ahead and tinker and learn and poke and prod and see what breaks and what, adjusts when you do this and that. And you get a little bit better understanding of what's really going on under the hood than if you just, go to a web portal and ask a question and get magic black box thinking answer back. This kind of gives you a more fundamental understanding of how these tools work. And I think you'll end up as a better AI user overall if you have tinkered yourself. So what does that actually mean? Getting set up. There are two important notes about your general models and how to make model choices. I would make, suggestions today and say, okay, Quinn 3.6, Gemma 4, things like that. But the reality of that is it's going to be different in 2 weeks, and then it'll be different again in a month after that. One of the things about this is there's just such an, gigantic flow of new things happening, new models, new things to choose from. Part of, really diving into the environment is keeping up with the news. You don't have to be to the day, to the hour, but if you're 2 weeks behind, you're probably with it. If you're a couple months behind, like there's probably something cool and new that you haven't quite seen yet. So most models are generally talked about as their general parameter count. This is the number of model weights that are in this thing. They're, in the billions of parameters typically for the things that you and I or most mortals will be running. They do run up into the trillions of parameters, but you better have a pretty hefty rig. We'll give a general ballpark of what these things mean in terms of your hardware in a second. In very rough terms, more parameters generally means more capability, but capability doesn't always mean performance to an individual task. Sometimes it can mean more breadth. Sometimes it can be more nuance of understanding. Ultimately, there's a lot of pieces that go into the recipe of building these models. And so, typically the more modern models plus a larger model will get you further than something smaller. So how do I run the bigger models? Of course, you may or may not have run across the concept of quantization. This is basically taking the full fat model, which is at a 16-bit precision, typically. A lot of the new ones are, however, trained directly at 8 or 4-bit, which is a little bit of a change of pace. But you'll generally run into a 16-bit, which means, the precision of each of these weights, which is basically like a float. It's number, dot, and, we'll say 10 decimals after that point, okay? That's not 16-bit, but to make the point, part of quantization is rounding that back to, okay, well, that last, 10th digit after the decimal, we don't really need to keep track of that. This doesn't make as big of an impact as we might have hoped. And so what happens in quantization is you're simplifying the amount of information while you're storing, the majority of what each of these weights is doing. So you can take a model, 16-bit to 4-bit, which is about a fourth of the memory total requirement, and you only lose, about 3 to 4% total accuracy in the model. There's lots of ways to measure that, but the general practice is, 4-bit is a very comfortable place that you would like to run a lot of these things on. Beyond that, when you get lower, you'll start to notice the models start to not behave quite as well. But most of the time, if you can go onto Hugging Face or something, you'll look at the number of quantizations of a particular model. You want to look for things that are in the 3 to 4-bit per weight. If that's all you can run, 4-bit and up is ideal. So what do I actually run this stuff on? If you are brand spanking new, you've never done any of this before, Llama and LM Studios are a great place to start. They are kind of all-in-one apps. You download these things, you kind of have an all-in-one place. They have UIs, they have a way to manage the models. You can, download models through them. I think that, I will caveat and say I don't particularly like them for general use, but I think they're a great place to start. And so, if you're just getting your hands into the game, pull one of those down, get comfortable. But then with the hope of kind of graduating on to some of these other service engines, llama.cpp is the kind of inference engine that actually underpins, for example, llama. Llama runs on top of llama.cpp. Llama.cpp is probably the most straightforward for a number of users to go ahead and use. If you've got a Apple, M series Mac, it's almost for sure the one that you want to look for. If you are specifically trying to run to a larger group, vLLM is a very popular, more specific for production tasks. It is designed around the notion that you probably have a couple more than just one or two GPUs, and you've got a lot of users. It has some very nice bells and whistles baked into it. I find that for an individual user, it can be a bit of a hassle. It's very particular. When you get it up and running and everything's, humming along, it's great, but it is considerably less flexible than a Llama CPP. I think you can run Llama CPP into, a few more bumps and bruises and it'll still keep going. And vLLM is really meant for somebody who knows how to make it work just so. SGLang is kind of a similar backend in the vein of vLLM, but it's an alternative. Take a look at it. It is worth your time. So if you are in the market for hardware, if you don't have hardware yet, and you say, I want to go and get some kind of hardware to run LMs locally, what does that look like? The industry has made it weird. They keep trying to sell you tops and AI laptops and this and that and whatever. At the end of the day, you really only care about your memory's bandwidth. If we're just talking about LLMs, almost all of the bottleneck for running these things is the memory bandwidth in your machine. If you have a GPU, that means your VRAM. If you go, a number of years back and get a NVIDIA 3090, that has about 900 gigabytes a second of, memory bandwidth in the VRAM. If you were to compare that to, a new fancy M5 laptop, you'll be, from like 180 to 450 range, depending on the things that you're choosing. If you are going out and buying that M5, new Mac Silicon, check very specifically which chipset and which memory you are choosing when you're going through, because they will have memory bandwidth implications. And like I remember I'm trying to show a couple people, oh, you should get this versus that. Check when you're, going through and specking the thing out. They'll have like a little button. I think it's like an eye or something like that that, pulls up the bigger rubric of details because, they assume a lot of folks don't care about that, and that's totally reasonable. But if you're buying specifically to say, I want to play locally with LLMs, you want to pull that up and say, this CPU that I was choosing that had, a couple fewer cores, well, it also had lower memory bandwidth option, and that should play in pretty heavily to your choice, because at the end of the day, that's going to give you almost a one-to-one change in how many tokens per second that machine is going to deliver. If it's like 30 tokens a second, it's pretty usable. If you can go up from that, it's great. If you go way down from that, it very much changes the types of patterns you can, set up. It comes from like an interactive routine that you're doing to like, okay, I'm going to set up a job and go get lunch and I'll come back when it's done. Sometimes that's the kind of interaction you need if you need to run a, particularly large model that's hard for your machine. As I mentioned, most of these models are measured in the, ballpark of billions. If you are shopping, I would suggest that the 30 to 34 billion parameter range model, where, if you're on a Mac, you'd probably want a 32 gigabyte minimum unified memory profile if you're looking for a GPU, either one or a couple GPUs if you must to get to 24 gigabytes as kind of like a nice entry point. These models are basically where you start to really have them be quite competent locally. Going up from there, obviously more, and you can make do with less. But that's kind of a comfortable local sweet spot to me. It's also worth noting that locally, as you want to work with more and more information in the context window, all of these inference engines need to pre-allocate that as memory, and that costs in your memory budget. So, if I'm saying, oh, a 32 gigabyte Mac can, run these models, it might only run these models with, 64,000 context window or something like that. And if you want to have, some massive one, you'll need more and more. So as with all things compute, more is always better, but you have to find that fine line of where it becomes useful to you in terms of efficiency and value. All of these points, we're presuming we were quantizing the models down to 4-bit. This would be 4 times larger to run it at 16-bit precision. There's almost literally no reason that you should ever attempt to do that unless you're a researcher or really, really trying to present some pristine model. Right. So what the heck do you actually do with it? You install all of these things, you get them all set up. Now what? Do I just chatbot with the thing? Well, you can, but there are a lot of other ways to go with these. And so, personally, my viewpoint is that at the end of the day, all the LMs are is a tool, and there's a lot of very useful, productive ways to put them to work for you. One of the most popular kind of ways of using LMs beyond the basic chat, which of course I think everybody's probably familiar with at this point, are code model kind of setups. Like if you've heard of Claude Code, OpenAI has Codex. All of these things are specifically geared towards having the LLM write, edit, read, work around code. This is a great superpower for somebody who is not a developer, who maybe had some cool ideas or maybe had a couple different applications before that didn't play nicely together. They want them to. It's a way to extend or build out something new. You say, I really wish I had that one productivity thing on my computer that I don't have. This is a great way to get started. Claude Code, it's great. It's hosted. You can purchase a subscription, get yourself kind of a general magic thinking box. But that's not the only way to get yourself some pretty reasonable coding options. There are a number of other applications. Continue, Klein, Open Code, Aider. I mean, there's only so much space on this. There's a lot more. It's worth looking, and all of these things will typically have integrations to VS Code, whatever kind of IDE you prefer, or on the terminal. These are a great place. I really enjoyed Rue Code for a while there. Looks like they had a bump in the road in terms of who was at the helm. It might be solved at this point. I haven't chased that down, but they were a great option as well. There is no one winning case. They all have trade-offs, and I think like it's kind of to the user to play with a few of them and figure out what works best for them. When you're starting to play with these things, the LLMs typically at this point will you'll set things up to have access to a few, kind of buzzwords, if you will, that help extend their usefulness to you. Tools, skills, agents isn't something that the element has access to. It's more something that is driving the whole show, but we'll talk about it. So tools, this is the oldest one. This is like, from right after ChatGPT landed, and like not too much longer after that, they figured out function calling. And what this is you give the model the ability under the hood, it's creating a little JSON structure that says, I want to call this tool I want to run it with these, arguments. Please go run it and bring back whatever the thing ran and returned. So those tools can be anything under the sun, basically. You hook this up to a function, more or less, and a function can have just about anything. So there are lots of optional tools that are available. If you've ever heard of MCP, that's Model Context Protocol, that's one way that has evolved to add tools to your setup. There's a lot of ways to run that thing down, but just remember you can make your own, especially if you've got a code agent set up. You can ask, hey, I really wish I had this tool. Can you walk me through it? Add that in. Now you've got that going forward. Helps you kind of customize your own experience. Skills, they're a bit newer and they need typically a bit more competent model. You're not going to really get a lot of use out of skills with a really small model or an older model, but skills are basically just pieces of text. It's saved as a markdown file typically. HTML is kind of coming into vogue as the new markdown file for sharing these things with your agents or LLMs or however you have this thing set up. But skills are mostly just, hey, this is how I want you to interact with this, service, this API, whatever. It's a cookbook in a way. It gives the LLM, information about what it should do in this context. It says, okay, you've come across this particular situation. These are the things that you ought to do. Note, it's just all suggestion. There's no hard and fast thing that now makes your agent or LLM, etc., do that thing. It is just, hey, LLM, these are some great ideas. You should do it. And if you have a very competent LLM, it will go and take care of that beautifully. If you don't have a particularly competent LLM, you might be tinkering for a while. So keep that in mind. Agents, if you've heard of OpenClaw or Hermes or any of Pi, etc. There's a number of these small agents. This is a fun one. I'll touch on some of these in a second. These are specifically kind of run in the background loops that continue the interaction with the model, and so the model itself is now given access to tools, services, all sorts of things. The more power you give it, the more security you want to make sure that you are wrapping these things in, of course. With great power comes great responsibility. I have to cringe as I say it, but it's perfect. This is your assistant. Like this is, set it up at, a little corner of your home and say, keep track of my organization, keep track of all of these things. Go, get a task, do some research, come back and tell me about it. Agents are great. They are quirky, they are fickle, they are a learning experience, but I think that they're worth, diving a little bit into just to get comfortable. They will get better, and as they get better, having a little bit of extra understanding at the ground point, you'll be more prepared to use them. These are some general frameworks that you can build with if you really start to want to hack and tinker. Again, there are a billion of these. Like there's a new one every other week. Open Hands is a great general purpose coding. It's got agents. Small agents is something from Hugging Face that's been around. It specifically kind of tries to have the agents run code to get things done. AutoGen, it's been around. Microsoft multi-agent kind of set up a whole bunch of agents to get things done for you. Pydantic AI is that's probably the nerdiest of the bunch and gives you kind of more lower level toolbox. A lot of the engineering group here at OpenTeams enjoys tinkering around that. That's one that we've found comfortable. I mentioned MCP servers. They're not really a framework, but they're something that you would tie in to a lot of this. Example workflow might happen on your machine. You set up an agent. Maybe it's a Hermes. Maybe it's small agents. Say, hey, I have this notes folder. Please go through that, read through them, summarize each file, make some clustered topics, give me a digest, and give me links back to the sources. You could also have this point out to, web research or something like that. These are just kind of general examples. What do you do when you run out locally? Like I mentioned, bigger models do more, and you will find yourself with a bit of intelligence cap. if you're just specifically running, your local laptop. Your machine, of course, you run these inference backends. You have total control. You can tinker. Um, Cost is the hardware plus the energy. Energy can, sneak up on you, but significantly less. After that, my favorite go-to is a general kind of aggregator. And there are a lot of these service providers that just host open weight models. Open Router is a very straightforward one that I've advocated a while now. It is a provider of providers. One of the things that you do want to keep an eye on if you go to Open Router is each of their individual service providers has their own terms of service. So don't just kind of read the front page and assume that everybody's on the same page. That's one of the ways that that could bite you if you have, some kind of data provenance, requirements. A couple of the providers might be great, and a couple of the providers might be not so great for your use case. Go ahead and read through each of those. Open Router does allow you to create, white and blacklist block allow lists. And so you can, specifically tailor it to like, oh, I like these providers. That might lower, the availability or the speed at which some of these things come back. I've never really had that happen in practical experience, but it could. But the best thing to me, and one of the great use cases of Open Router, is you can go and you try all the fun new open models and see what it gets you. If you're in the market for new hardware and I got that, burning need. There's a hole burning in my pocket. I want to go get that cool new shiny piece of hardware. Go try what models that thing will actually enable you to run and say like, oh, this is way better. This is exactly what I want. Or like, oh, that didn't quite do it for me. I need a bigger one. I can't afford that one. But some of these models are quite a bit cheaper. DeepSeek V4 Flash, I just looked at the other day, is like 22 cents per million tokens output versus, Gemini 3.5 Flash, these names, that was just from Google I/O. It's $9 per million tokens output. And that's the Flash are usually they're like small, efficient models. Now, Gemini 3.5 is a bit better, but is it so much better that $9 versus 22 cents can, really make or break? That'll be up to your use case. So direct hosted API, of course, beyond the chat window, beyond the web portal, Anthropic, OpenAI, Google, all of these sorts of providers will also give you API access to actually hit their models. These typically are by far the most expensive route you could possibly ask for. You go and run Anthropic's top of the line model, and that 22 cents that we mentioned, or the $9 is now $25 per million tokens output. For some use cases, it's the only option to get that performance level that you really need. But you probably want to use that carefully, sparingly when you really need it. These processes don't need to just rely on one model too. You could run 80% of your workload, workflow, whatever it is, on one of these cheap models, and then when it comes to the hard part, whatever that is, pay a little bit extra for the really smart thinky thing. Say, okay, $25 per million tokens for this little piece starts to make more sense, but you don't want to, ask it the weather. And then, of course, there's all of the cloud GPU rental options. You can run Pod Lambda, Modal, all of, Azure, AWS, those sorts of things. They'll all have kind of a different type of user experience, product and the way you get hooked up. You control the stack. That's the nice thing. You still have, mostly the whole set of software is something that you choose to run. You set it up, you can tinker, you can modify the models. So it's not quite like the, provided for you APIs with the routers and the direct hosted APIs. So like it gives you some of the control back that you would have locally. But of course, finding the GPU availability can be tricky if you're trying to do it on the fly, et cetera, et cetera. So there's no silver bullet in a lot of these things. Say try it tonight. If you're new, pull down llama LM Studio. They set up pretty quickly. Pull Win36 or Google 4, Gemma 4, and hook up one of these particular interfaces. Continue Hermes general chat. One thing that I didn't mention earlier is Unsloth Studio. It's a little bit newer and worth a look for people who are more on the tinkery side of things. You want to start, getting your hands dirty. You want to start training specifically. And they have a lot of really cool helper things set up, and it's open source, and they do a lot of great community work. Highly recommend taking a look. So, questions. I did see at least one in the chat that I want to make sure we get to first. The base M5 model with 32. So I don't remember offhand which is which in terms of the memory bandwidth, but as I mentioned, like you would basically want to go into, the configuration. You know what? We'll just do it. Let's do it. Apple. What better way to talk it out what I'm actually talking about? Laptops, MacBook Pro. Some of these are going to be expensive. Watch out. So, you'll notice that there's a 14-inch, 16-inch. They have different options. Your 14-inch has M5, M5 Pro, M5 Max. 16 does not have just M5. So, okay, we're going to go here. Oh, I have to pick it. It's so silly. You have to pick a color first. It's like, okay, guys, I see the priorities. So let's say, okay, I got this one where this is where it is. They changed their UX, but it's like, oh, do you need help choosing? Yes, I do. Then it pulls up this little thing. So your M5 down here. No, does it not? There we go. There we go. So 153 gigabytes per second memory bandwidth. That is going to be painful if you're trying to run a local model. Now, doesn't mean it's not going to do it. It means you're going to make, trade-offs. You're going to say, I'm going to either run smaller ones, something I didn't mention before. Mixture of expert model means that the total number of parameters is huge, but for any particular token, it is chosen, a lane on the road, if you will, that only runs a certain subset of those parameters. And so it's cheaper to actually make that inference pass. So those are great options. In general, for a lot of the Macs, they have a ton of memory and not a ton of speed, unless you're paying for the really, really fancy studios. The MOE models are a fantastic fit to what the Mac Silicon is providing in general. So we looked at M5, it's 153. M5 Pro, there's two configurations. Gotta watch out. Oh, but they're the same. 307, it's double, that's great. It's not so bad. Then you go up to the Max. This is where it can sneak up on you. 460, competent, but there's also another option if you get the 40 core GPU instead of the 32 core GPU. So that's where I mentioned, like, you got to really look there. It's not straightforward, and it's kind of annoying. That is, but their typical audience isn't specifically trying to optimize LLM inference. This one I can almost guarantee is going to be a good price step up. But if you're not looking at price, this is for sure the winner. This GPU, get 614 gigabytes per second. It's not going to match, NVIDIA GPU. If you go and buy a 5090 right now, it's going to cost more than this whole laptop, probably, given current prices. Probably 4,500, I bet, without looking. That'll have 1,800 compared to the 6. So, it's 3 times faster. And so it'll almost literally give you a 1 to 3 kind of change. It's not exactly that, but that's the rough ballpark. Insights running NVIDIA in Windows versus Linux. Windows has slightly faster drivers, typically. Yeah, I like Linux. I work on Linux. It's more comfortable. It's easier to, make a mess as a developer and like do things in. So I don't love Windows for kind of the PyData ecosystem development. But, if I just go and install the same kind of like inference engine on Windows and on Linux unless I've spent a good amount of my precious free time. I do have two kids who like to steal all of that from you as much as you love to give it. Um, the Windows one is just going to be a little bit faster. When I was recently testing, I think it was Quen 3.6, the MOE on Windows, I was getting like 135 tokens a second on a 3090, and it was like 95 to 105 on Linux. Now, there's probably a way to get one to the same parity, but it's going to, need a little bit more kind of tinkering under the hood. So yeah, figure out what the priorities are. If it's easy to set up and you're just doing LLM service, Windows might be great. Probably has a slightly better NVIDIA driver. Now, that's all with the caveat that I'm assuming you're talking about consumer GPU, and like if you're going off into service and cloud and, the big boy things, it's going to change that kind of profile. Mac Mini. Uh, like we said, it's gonna come down to this one line there. Willie, you're gonna have to have the memory bandwidth. If we go back, um, Mac Mini. This is a great cheap option. It's nice to set something up and throw it in the corner. I think the real reason that these things became popular was when OpenClaw came around and everybody wanted a nice little sandbox. Why do I have to? Okay, just click the configure. Click the thing. Let's find out. Ooh, you don't want that. Let me tell you. Um, this is M4 to be fair. 120 for memory bandwidth, that's going to be painful. I can guarantee. 273, that's competent. This is on the order of what you're going to get from a DGX Spark or a Strix Halo, which are the 128 gigabyte kind of big bunch of memory that are meant to have kind of the AMD or GPU or NVIDIA, GPU. But, they're they're school buses. They're meant to get you something big, traveling the distance, but it's not going fast. And you buy it with that in mind. So like we were talking, your 5090 is 1800. Now we're at 270 here. It'll do it. You'll just have a different kind of cadence in what you expect. For live like code interactions, I would be very frustrated running at that. Um, Unless it's kind of like I'm giving it information, I'm setting up some kind of system that'll run autonomously, and I'm gonna go get coffee. That would work. That kind of pattern would work great. But if I'm trying to, chat with it back and forth, you're gonna be waiting. Um, I don't even particularly love doing that with my local, which right now is a 3090, which is about 900. It's doable. It works. But they're all trade-offs. All right. Any other questions? I love questions.
I have a couple of questions, but I will wait for half a minute, maybe less, for questions from our audience. And feel free to use audio. We are a pretty small group, so audio is fine. And of course, the chat is always there for you. All right. Well, while you're thinking about your questions, the question I have for you, Dillon, is around the governance and specifically what governance challenges emerge when every developer can independently deploy, fine-tune, and automate AI capabilities outside of centralized platforms or approval processes?
Uh, that's a big question. That's a bit loaded. So if you are Hmm. Let's think about that. There's a lot of layers to this. Obviously, that will depend on your organization, the type of kind of organization. If you're, academia, you've got a research wing. I think that sounds great. Let's do it. Everybody gets their own thing. Everybody, writes up their paper and you talk about it. If you are a silo in a gigantic corporation, and employees come and go and like processes need to survive, I think that sounds like chaos. Um, the main thing there is you would hope for some sort of rough reproducibility. Um, with LLMs, they are by nature non-deterministic, which means you're not going to get an exact one-to-one, um, for any general process to begin with, but you'd like it to be as close as possible. So like, if you have some senior, developer who's built out this wonderful, great kind of thing that, does something useful for the company, um, something bad could happen. They get sick, they have to go on leave. Who knows? Something great could happen. They have a kid. They're gone. You don't want that specific pattern to be tied to, oh, they had their one LLM that's been, tinkered, and maybe you do, but if you do, that needs to be saved, shared, versioned, pinned, tagged, everything type of artifact that everybody can pull down and say, for Dillon's workflow 3.2, we know that this runs with, Qwen 3.6 plus his three lures that he built and these kind of extra. Um, these are platforms, these are services that you kind of build out, some kind of model tracking, versioning, something to pull down, something to keep track of where things go. Um, but, I'd say that becomes an institutional conversation. Um, we do those sorts of conversations with clients all the time. I love having those conversations, but there's no one size fits all.
This is it is indeed a very complex topic. It would take a lot more time that we have remaining in this session. Igor, you raised your hand, please.
I got a quick question. Thank you, Dillon, so much. Highly exceeded my expectations, so I'm glad I joined.
Oh, thank you, thank you.
So, question I have on models, they tend to produce answers for things they don't know. Have you
Sure do.
seen any progress on getting models to actually say, I don't know, instead of producing something?
Um, yes, but you also want to first fully recognize that they don't know that they don't know. And so you're asking a very challenging question of them because at the end of the day, as wonderful tools as these things are, um, they don't have an internal kind of ego. They don't have a sense of, I know this stuff. They don't know what they don't know. And it facetiously, everybody at the beginning, oh, it's just an X token predictor. It's just, a stochastic pair, whatever. Yes, it is all of those things, but it still gets you, OpenAI just solved, a very complicated math problem, disproved a portion of it that, professional mathematicians had been fighting over for a long time. Now, there's a whole bunch of conversation to have about that. Oh, it's kind of like, being able to explore this semi brute force, blah, blah, blah. But the point is, you can get some really cool stuff achieved with these things. I don't think that we are any closer to being able to have an LLM tell you that it doesn't know something. Different LLMs do have different kind of hallucination rate profiles, but I'd also argue that at the end of the day, a hallucination versus a, honest answer, they're not, fundamentally so different under the hood. It's just the next most likely thing that's supposed to come next. Um,
Have
in a way,
you
that's a double-edged sword. Sorry, yeah,
have
go
you
ahead.
seen people connecting it to, like, this is an inference engine, but also connecting it at the same time to a knowledge database that it
Oh,
could verify
absolutely.
against that?
Yeah, so that was one of the very first things that a lot of folks did was, okay, RAG, if you've heard of it, is oh gosh, it's been so long. Retrieval augmented generation. Um, RAG was vogue, Pinecone and all of the vector databases. And the notion was that you would take, your knowledge base, textbooks, institutional knowledge, and you take it all and you chop it up and you segment the information because at the end of the day, your LM only has so much context window that it has to work with. You take all of that information, you make it, these little bite-sized useful nuggets, and then you embed against that thing, which is a model that has learned to, know the features of that particular set of information. You can train these embedding models on your own kind of corpus of information so they know your stuff better. But then you ask a question and it says, oh, based on this question, these 5 little chunks of information seem to, based on some cosine similarity lookup, fit most likely, and we're going to dump them in. Now, that whole pattern, there's tons of money behind it. So, of course, they made it very, very, complicated. You can, do hybrid search where you've got sparse and dense encoders and they all work together. At the end of the day, it's running like a Google search, ish on the data that you have and putting that into the model. What I prefer now is more of a agentic pattern. Where you give the LLM the tools to explore and discover and say like, hey, LLM, here's a folder of, 10 research papers that have all this stuff. Now, I've given you a tool to go into that folder and read a file. I've given you a tool to go into that folder and read a subset of that file so you don't have to stuff, a 17,000 page document into your context window and you just choke on it. But you allow through kind of iterative approach the LM to build out its own context and almost, like you were an intern and you were given a task. Oh, go figure this out for me. Go look in the, internal private documents. Goes and does that. That's going to be a much slower, more expensive process than, RAG. RAG is like, boom, here's your answer. Or, at that point, everybody felt, we have to have the answer coming back instantly. And so it gets the information, dumps it in the context, it answers. But it's not always going to be, perfect. This is an evolving kind of art, and like the great thing is it is moving so fast. Your new crazy idea could be the new state of the art in a month, Take RAG, take some of the agentic, play jazz, do something crazy. And so like that's part of the game that you play is, you might start with the RAG kind of and like ask the agent, maybe a smaller model. Is this enough information to answer that question? And it'll say, yeah, I can. And it just answers it. Boom, you're done. But if it's not, here's a gigantic stack of tomes. Go read through it, figure out what you need, ask the user a couple questions, follow up, say, oh, actually, I'm not sure I entirely understand the purpose of your question. Oh, now I do. Okay, now I'll go read chapter 5 or whatever it is. The end of the day, each of these models has a limited context window, so you're always fighting that tension of like kind of like using it effectively versus like getting something functionally done. Yeah.
Very, very cool. I appreciate the context. Thank you.
Absolutely.
Those are great questions, Igor. Thank you for asking. Well, we're at time, but I really want to ask this question, Dillon.
Please.
With my head of open source program manager. This is something that was asked quite a few times at the PyTorch conference back in October. This is how it goes. We were talking about open source AI ecosystem, and that suggests that everyone can contribute. I'm curious what you think. How can individuals and organizations can contribute back to the open local ecosystem beyond just consuming models?
Oh, goodness. That's it with the easy questions today. That's going to be a scaled approach. The most straightforward, of course, is, if you tinker and you build something cool, you share it. It's a new Git repo. Hey, this is the cool thing that I did. Like some of the things these days that like have the most traction are just somebody built like a cool new skill that works really well with, the LM. It's like, I was reading the other day about, grill me, and now there's a new version, grill me with docs. the whole concept of you kind of come in with an idea of what you want to build, but then you have the LM ask you a whole bunch of questions about it to try to come to some kind of, coordinated, organized solution before you start building. So that's one thing, everybody is learning, and like there's no one size fits all solution yet to just about anything. Sharing information, getting involved in forums. With all of these things, there are proper um, modules, Python, etc., further abroad, NPN, etc., that are actual, code bases that are attempting to do things. Making contributions to those is always fantastic. If you've got like, oh, I really love Pydantic AI, but I wish it did XYZ. Start an issue, build a PR, work with the, maintainers, see if they want it there as well. If they don't, maybe it becomes your own little thing, your own fork, depending on the licensing, etc. Obviously, contributing back is great. The whole concept of using or not using AI will change depending on, where you're doing that contribution. Some places are overwhelmed with just like stuff produced by some questionable AI processes. And so you'd want to be very careful when you're making those contributions. I haven't yet found a really good place where LLM lores are shared and traded. I think that'd be really cool. Somebody should go build that, or tell me where that is, if that is. That exists for all of the image and things, Gen AI. There's all sorts of, things that have, shareable lores. I'd love to see that for LLMs.
Thank you, Dillon. Well, we are at time well beyond 5 minutes beyond time. I don't see any more questions, so we will close the event. I see somebody just joined. Ellen, welcome. We did the recording, but we are just about to wrap up. And Dillon, thank you for your presentation. And to our attendees, thank you all for spending time with us today. I know you have a lot of options and it's a work day, so thank you, thank you. I'll be posting the presentation on the OpenTeams YouTube channel in the coming days. So if you missed anything or just want to revisit the highlights from today's presentation, keep an eye out on your inbox. And yes, I really appreciate you all being here. Have a great day.